topic number 4 out of 5. We have today, and we have tomorrow, and we have reviewed everything from the year. Isn't that crazy? Everything in a half a year and 5 days. So this 4th topic is characteristics of quadratics. Remember, like, if we're talking about a person's characteristics, you might be like, they're tall, they're short, they have brown hair, they have brown eyes or blue eyes. You know, it's special things about a quadratic, and there's really 4 things we need to be able to do. We need to be able to say what form it's in, which there are 3 possibilities. We need to be able to find the axis of symmetry and the vertex, which are almost exactly the same thing. And then we also need to tell if it's a minimum or a maximum. So you're looking at this and you're probably like, where's this on my sheet? These are just some generic notes that you can put down in that empty space down in the free response. If you do it off to the side, you can take these little notes. They're good to take. So let's go ahead and start. So there are 3 ways to write quadratics. Okay, vertex form, standard form, and intercept form. We've been working with standard form a bunch. Standard form is what it looks like when we were factoring, what it looks like when we were doing the quadratic formula, what it looked like when we were modeling them. It's the most common one. Intercept form we also call factor form, and then vertex form is also called transformation form that we haven't done a lot with, just a little. So vertex form looks like this. Y equals a times x minus h squared plus k. Oh, just in the open space in the free response. Anywhere over here. Just look right here to do notes. Not, like, just right here. No, that's a separate problem.
Gotcha.
Okay, so that's what vertex form looks like. If you want a little example, here's an example of one. Y equals 2 times x plus 3 squared minus 4. There's an example of a quadratic written in vertex form. Okay, now you don't need to know or memorize the generic form with the A, H, and K. All you need to be able to do is look at it and be like, oh, look at that. That is in vertex form. Okay, vertex form has 1 pair of parentheses. It's a good way to remember. Okay, standard form. The most popular way you will see a quadratic formula for the rest of your life. On the ACT, SAT, and math after this, college, whatever your plans are. Standard form is our A, B, and C. Y equals AX squared plus BX plus C. AX squared plus BX plus C. An example that I'm just going to make up might be 2x squared plus 6x minus 4. That's an example of standard form. There are no parentheses in standard form. It's just our 3 terms with our A, B, and C. And last but not least is intercept form. This is also factored form. So it looks just like when we factor a quadratic and we have our 2 sets of parentheses. It's called intercept form, but we call it factored form a lot. Y equals A times x minus p times x minus q. There's that p and q from factoring. That A is really our greatest common factor, but that's a lot like what we see when we're asked to factor a quadratic. Example might be y equals 2 times x minus 3.
Is that P or Q?
Oh, it's a PQ. Okay, there's an example of intercept form. Now, what's super nice about this topic is almost all of it is done as long as we know how to work our calculator. For each problem, no matter what form it's in, we're going to put it in our calculator and we can find all the information we want just by using our table and our graph. So the big thing here is we need to be able to find the vertex and the axis of symmetry, AOS, axis of symmetry, and the vertex. Now, when you are trying to find the vertex and the axis of symmetry, which we'll see in just a second, is you need to think of a sandwich. I know this is silly, but you're going to think of a sandwich, okay? When you go to your table, here I'm going to give an example. This would be awesome to write. One more. You are going to look for a sandwich. You are going to go to your table, and you can figure out what your vertex is. For example, let's say my vertex is the point 2, 3. 2, 3. You are going to look for the number that is sandwiched between two of the same numbers. So what it might look like is this. If I look right here, do you see what I mean by sandwiched? What is the 3 sandwiched between? 2 10s. Okay, and actually the sandwich keeps going. Above this maybe is 20, 20. Okay, you don't really care about the left side. But see how that number is sandwiched by the same numbers? They're in the same spots. We call this symmetry, which is why it's called the axis of symmetry and the vertex. The vertex is right in the center. So you will have a point that's right in the center of your table that is sandwiched between the same 2 numbers. Okay? Quadratics always follow this pattern. Now, we could do this with formulas and stuff, but if you can realize when you have a sandwich, you'll be able to find the vertex and axis of symmetry. The vertex is the point. The vertex would be the point 2, 3. The axis of symmetry is just the x value. Okay, so let's do this. Okay? The first question on your midterm is a multiple choice question. And it asks us, which of the following quadratic does not have an axis of symmetry of x equals 3? Now, this is not a very hard problem. It sounds pretty hard.
So this question this one up here will literally be on the midterm.
Correct. I just scrambled it. So it's just like this. Okay, so calculators are the most important thing to have right now. So I'm going to pull up my calculator. Should have had it already pulled up, but I'm slacking today. I'll make my screen nice and big for you guys. Okay, so I need to find each of these options axis of symmetry. And we're going to do that by looking for that sandwich. Okay, so the first thing I need to do, if I'm doing our first one, is I'm going to click y equals. I first need to type in my equation so that I can go to the table and find the sandwich. So I'm going to go here and I'm going to type in 1/2, 1 divided by 2, Mr. Tokar. No. I'm going to type in 1/2 parenthesis x minus 3. I'm typing in this equation right here.
How'd you get to the top right?
So the which part? Oh, y equals in the top left. Squared plus 4. Okay, so I have my equation typed in. If you guys remember from earlier in the year, above the graph button is the word table in blue. See it? So you're going to click second graph to go to our table, and we are looking for a number that is sandwiched. Which number is sandwiched between the two same others? 4. See how it's sandwiched between 4.5 and 4.5? Okay, that means 4 is, 3,4 is the vertex. Okay, now sometimes you might have to click up and down to search through your table, but that means 3,4 is the vertex, but 3 is my axis of symmetry. So my first equation, 3, is the axis of symmetry. So we're going to write that down. But remember, my question said, which of the following does not have an axis of symmetry of 3? This one did, so it can't be A. Does that make sense so far? Okay. We are going to now check B. So we go back to y equals. We're done with this one. We can clear it out. And now I'm going to type in my second one. 2x squared minus 12x minus 8. So make sure you have that typed in. Double check that it's perfect. And now I'm going to go to my table, so I'll click second graph. And I'm looking for that sandwich. Does anyone see the sandwich? Yeah, negative 26 is sandwiched between negative 24 and negative 24. And so if I go look at my x value, so my vertex is the point 3, negative 26. My axis of symmetry is 3. So again, B has an axis of symmetry of 3 as well. So B is also not my answer. I'm trying to figure out which one doesn't have an axis of symmetry of x equals 3. Okay. Again, not hard, a little tedious. Okay, so we go to C. We need to figure out what C's axis of symmetry is. So I go to my y equals, clear out that old graph, and I'm going to type in C. Parentheses, x plus 2, and x minus 8. And I'm going to go to my table, second graph, and I'm looking for that sandwich. And there again, here's our sandwich. Negative 25 is sandwiched between two negative 24s. So that means my vertex is at 3, negative 24. My axis of symmetry is, again, 3. So C has an axis of symmetry of x equals 3. Can't be C. Which means which one's our answer? It's got to be D. Well, I'm just going to plug it in really quick just to show you. But if I click my y equals and clear this out, I have 3x squared plus 9x plus 6. I go to my table, and if, I didn't hit second graph. If I go to number 3, is this number sandwiched? No, it's between a 36 and a 90. That's not sandwiched, so 3 is not the axis of symmetry, which means D is the answer. Does that make sense? Okay, so that's the multiple choice. Identical, just like this. You plug in your equations and figure out which one does not have the axis of symmetry. Type it in, go to your table, and so on and so forth. Alright, so let's do a full free response problem. Okay, this is what your free response is going to look like. I can even make it a little bigger for you guys. Okay, on the free response, you need to be able to do 4 things. You have to be able to write down the name of the form it's in. Okay, so either standard, intercept, or vertex. You need to be able to find the axis of symmetry in the vertex, which is what we just did in our calculator. And then you're going to use the graph to figure out if it's a max or a min. I know it says mix, it's supposed to say min. Typo, my fault. Alright, so here we go. When you look at this, which form is it in? If you look at those little notes we took earlier. Standard. One easy way to tell standard is there's no parentheses. It must be standard form. Also, this is our ABC we're used to seeing a lot. So you're going to write standard. Oh, there's definitely a D at the words at the end. That's standard form. And now it's time to find that axis of symmetry and the vertex. And now remember, all of this is all done. My smart board is on something today. This is all done in our calculator. Okay? Don't have to use any formulas. Don't have to do anything crazy. We're just in our calculator. So let's go to our y equals. If you have something in there, go ahead and clear it out. And let's type in our equation. 1/2, which we just type in 1 divided by 2, that's our 1/2. X squared plus 4x plus 6. That is my standard form quadratic. Now we're going to go to our table and we are going to look for the number that is sandwiched. Second graph. Okay? So when I look at this screen, do you guys see a sandwich number? I don't. Right? I don't see a number sandwich, which means I gotta go searching. So I'm gonna click up to go look above. Okay? Now I do. Do you see a sandwich number? Which number is sandwiched? Yeah, -2 is sandwiched between -1.5 and another -1.5. So remember, sometimes you might have to scroll up or down to find it. It won't always be on that starting screen. So just be aware that if it's not on your screen, it doesn't mean you did something wrong. It just means you might have to go up or down to find it. So the point -4, -2 is sandwiched. That means that point is my vertex, and my x value is my axis of symmetry. So -4 is going to be my axis of symmetry. The point -4, -2 is the vertex. Does that make sense? So my axis of symmetry is the x value. X equals -4. My vertex is the whole point, both numbers, -4, -2. And that's because if we take a look at this graph, we have something that looks like this. My vertex and the line that cuts my quadratic in half, the axis of symmetry, they go through the middle. The vertex is in the middle and the axis of symmetry goes through the middle. So that's why those values are the same. Okay? To figure out if it's a max or min, not mix, min, you just click the graph button and you look at the quadratic. Is this quadratic's vertex at the bottom of it or the top of it? Right here? At the bottom, so this is a min. It's a min. Well, here's what it would look like if it was a max. This one isn't a max, but just, let's say I did this. If your quadratic looked like this and the vertex was up there at the tippity top, that's what a maximum would look like. Okay, so that's the whole thing. Most of it's done in our calculator. So that is the characteristics of quadratics that you need to be able to do on your midterm. One multiple choice and one free response, just like this. Make sure you know that three forms. How to find your sandwich number and write down your axis of symmetry. Make sure for axis of symmetry you do x equals your x value. Vertex is both the x and the y, and then use your graph to see if it's a max or a min. And that's it. That's characteristics of quadratics.